the particle description of light. So a quantum of energy is the minimum quantity of energy that can be lost or gained by an atom. So each particle of light contains a specific amount of energy called a quanta, and Einstein called these light packets photons. So this brings us to our next equation. Okay, German physicist Max Planck proposed the following relationship between a quantum of energy and the frequency of radiation. So this is E equals h nu. So E is our energy, which is measured in joules. So symbol capital J, frequency is the same as our last equation, frequency is nu, and h is nu, it's Planck's constant. That's 6.626 times 10 to the negative 34th joules times seconds. All right, so we have a couple calculations here. Now I'm going to go back here. I want to give you another equation to use, which is very helpful. It'll be helpful for the last example problem that we do. So another equation to calculate energy, E equals hc over lambda, right? So E is energy, same thing, units joules. H is Planck's constant, c is the speed of light, and lambda is our wavelength. So it says, what is the energy per photon of radiation with a frequency of 6.75 times 10 to the 15th hertz? So if they give me frequency and I'm looking for energy, it'd be a good idea just to use E equals h nu. So E equals 6.626 times 10 to the negative 34th and our frequency 6.75 times 10 to the 15th. So all I need to do is multiply these two numbers together. E should equal 4.47 times 10 to the negative 18 joules. Okay, now it says the spectral line of lithium occurs at 671 nanometers. Okay, before I even change anything else, before I even look what I'm calculating, I see nanometers there. I know I need to change that to meters. I already know that. Okay, so now I want to calculate energy. Now, I'm going to erase this because there's not a lot of room here. 6.7 times 10 to the negative 7th meters. That's our wavelength. All right, so our formula, E equals hc over lambda. And we're going to use this equation a bunch when we do the flame test in the next few days. So E equals, h is Planck's constant, so we plug this in our calculator, 6.626 times 10 to the negative 34th times 3 times 10 to the 8th. And you should get your numerator 1.9878 times 10 to the negative 25th. Divide that by 6.71 times 10 to the negative 7th. And you should get your energy to equal 2.96 times 10 to the negative 19th joules. Okay, so the particle description of light. The previous equation represents the energy of a photon. So a photon is a particle of electromagnetic radiation having zero mass and carrying a quantum of energy. The energy of a particular photon is directly proportional to the frequency. Okay, so the equation we just looked at is directly proportional. In the equation we used before would C equals lambda nu, so wavelength and frequency are inversely proportional. And the energy of a particular photon depends on the frequency of the radiation. We've already talked about both of these formulas. All right, so E equals hc over lambda and E equals hv. Energy of a photon, same exact formula. Okay, so the hydrogen atom line emission spectrum. The lowest energy state of an atom is its ground state. And we'll learn about this a lot more in our next video. A state in which an atom has a higher potential energy than it has in its ground state is an excited state. Okay, when you're at your lowest energy level, you're on the ground, right? As you go up, right, it's an excited state because there's more energy. And usually, when you have more energy about something, you're excited. So when investigators passed electric current through a vacuum tube containing hydrogen gas at low pressure, they observed the emission of a characteristic pinkish glow. When a narrow beam of the emitted light was shined through a prism, it was separated into 4 specific colors of the visible spectrum. The 4 bands of light were part of what is known as the hydrogen line emission spectrum. And here it is here. Right, so the excited hydrogen atoms emit a pinkish glow when the visible portion of the emitted light is passed through the prism. It is separated into specific wavelengths that are part of hydrogen line's emission spectrum. So the Bohr model of the atom. See, Niels Bohr proposed a hydrogen atom that linked the atom's electron to a photon emission. According to the model, the electrons can circle the nucleus only in paths or orbits. The energy of the electron is higher when the electron is in orbits that are successful farther from the nucleus. And our last thing today, talking about the Bohr model of the atom, when an electron falls to a lower energy level, a photon is emitted, right? And when you emit something, you take it out, you exit, right? And this process is called emission. Energy must be added to an atom in order to move an electron from a lower energy level to a higher energy level. So when you take something in, right, or gain something, this process is called absorption. And this concludes our video on the particle description of light.